From the moment we open our eyes, we are swept away by time's relentless and unyielding current. It's the silent orchestrator of our lives, marking birthdays, seasons, and the rise and fall of entire civilizations. But what exactly is time, really? Where did it come from and how did it begin? And will it ever come to an end? In the grand tapestry of the cosmos, time is one of the most fundamental yet perplexing threads. For physicists, it's a dimension, woven into the very fabric of space-time itself. For philosophers, it's a river of moments, constantly flowing from the past through the present and into the future. Throughout history, brilliant minds have grappled with the enigmatic nature of time. Ancient philosophers like Heraclitus pondered its constant motion and change, while modern physicists like Albert Einstein revolutionized our understanding of its relationship to space and gravity. Yet despite centuries of inquiry, time remains one of the greatest mysteries of the universe. Join us as we embark on a journey through the cosmos, exploring the origins, nature, and possible end of this elusive force that shapes our very existence. Our journey begins with the Big Bang, the cataclysmic event that birthed our universe approximately 13.8 billion years ago. This monumental explosion marked the beginning of everything we know, from the smallest particles to the vast galaxies that stretch across the cosmos. It was a moment of unimaginable energy and creation, setting the stage for the universe's grand unfolding. But did time itself spring into existence at that very moment? Or did it exist before the universe as we know it? This question has puzzled scientists and philosophers alike for centuries. If time began with the Big Bang, what does that mean for the concept of before? Can we even comprehend a before in the absence of time? Some theories suggest that time may be eternal, existing even before the Big Bang. This idea challenges our understanding of time as a linear progression from past to future. If time is eternal, it implies a reality where time has no beginning and no end, an infinite continuum that stretches beyond our comprehension. Perhaps our universe is just one chapter in an infinite series of cosmic cycles, each with its own beginning and end. In this view, the Big Bang is not a singular event, but part of a grander cosmic rhythm, where universes are born, evolve, and eventually collapse, only to give rise to new ones. This cyclical nature of the cosmos suggests a timeless dance of creation and destruction. Or perhaps time itself is a fundamental property of reality, existing independently of any universe. In this scenario, time is an intrinsic aspect of the fabric of existence, not bound by the physical universe but a constant backdrop against which all events unfold. This raises profound questions about the nature of time and its relationship to space and matter. Other theories propose that time emerged alongside the other fundamental forces of nature during the Big Bang. In this framework, time is intertwined with the very forces that govern the universe, such as gravity, electromagnetism, and the strong and weak nuclear forces. The birth of time is thus seen as a simultaneous event with the birth of these forces, all emerging from the same primordial explosion. In these models, time is inextricably linked to the expansion of the universe, with its very essence woven into the fabric of space-time. As the universe expands, so does our understanding of time, suggesting that time and space are not separate entities but part of a unified continuum. This concept, known as space-time, revolutionizes our understanding of the cosmos and our place within it. While we may never know for certain what came before the Big Bang, or if before even has any meaning in such a context, the quest to understand time's origins takes us to the very edge of our current knowledge. It challenges us to think beyond the limits of our perception and to explore the deepest mysteries of existence. The search for time's beginning is not just a scientific endeavor, but a philosophical journey that touches on the very essence of reality. It's a journey that pushes the boundaries of physics and cosmology, forcing us to confront some of the most profound questions about the nature of reality itself. As we delve deeper into the mysteries of time, we are reminded of the vastness of the universe and the limits of our understanding. Yet it is this very quest for knowledge that drives us forward, inspiring us to seek answers to the questions that have fascinated humanity for millennia. The origin of time remains one of the greatest enigmas, a puzzle that continues to captivate the human mind. We experience time as a linear progression, a relentless march from the past through the present and into the future. But is this perception of time's flow an accurate reflection of reality, or simply an artifact of our human consciousness? Einstein's theory of relativity shattered the notion of absolute time, revealing that time is relative to the observer's frame of reference. Time slows down in strong gravitational fields and at speeds approaching the speed of light, suggesting that our experience of time's passage is not universal. Some physicists speculate that time, as we perceive it, might be an illusion. Perhaps the past, present, and future all exist simultaneously, and our consciousness simply traverses this pre-existing timeline like a traveler on a predetermined path. If time is indeed an illusion, it raises profound questions about free will and determinism. If the future is already written, are our choices truly our own? Or are we merely actors playing out predetermined roles in a cosmic drama? Section 4. Time's eventual curtain call. Just as the universe had a beginning, will it also have an end? And if so, what fate awaits time itself? The universe as we know it began with the Big Bang, an event that set everything into motion. But what lies at the other end of this cosmic journey? Will it simply cease to exist? Or will it transform into something entirely incomprehensible? The nature of time is one of the greatest mysteries in science. Could it be that time as we understand it is just a temporary construct? One possibility is the Big Crunch, a scenario in which the universe's expansion eventually reverses, leading to a catastrophic collapse back into a singularity. This would mean that all matter and energy would be drawn back into a single infinitely dense point. In this scenario, time, along with space and matter, would be compressed out of existence. The very fabric of reality would be torn apart, and the concept of time would become meaningless. Another possibility is the Big Freeze, where the universe continues to expand indefinitely, becoming increasingly cold, dark, and empty. As galaxies drift further apart, the energy that fuels stars and planets would dissipate. Stars would eventually burn out, black holes would evaporate, and the universe would approach a state of maximum entropy, where time itself might become meaningless. In this frozen, desolate state, the universe would be a shadow of its former self. However, some theories suggest that even if our universe meets its demise, time might persist. Could time be an eternal entity, existing beyond the confines of our universe? Perhaps new universes could emerge from the ashes of the old, each with its own unique arrow of time. The concept of a multiverse opens up endless possibilities, where each universe has its own timeline and set of physical laws, or perhaps time in its most fundamental form exists independently of any universe, an eternal backdrop against which the cosmic drama unfolds. This timeless stage could be the ultimate constant, unaffected by the birth and death of universes. Section 5. Is time our universe's fabric? This question has intrigued scientists, philosophers, and thinkers for centuries. Time, as we perceive it, seems to flow in one direction from the past to the future. But is it really that simple? Einstein's theory of general relativity describes gravity not as a force, but as a curvature of space-time. This revolutionary idea changed our understanding of the universe. Massive objects warp the fabric of space-time, influencing the motion of objects around them. This warping effect is what we perceive as gravity, and it affects everything from the orbits of planets to the path of light. This raises a profound question. If space can be curved and warped, what about time? Can time be bent, stretched, or even traveled through? Is time simply a component of this cosmic fabric, inextricably linked to space and matter? If so, how does it interact with the other elements of the universe? If time is indeed woven into the very fabric of our universe, then its properties and behavior would be governed by the laws of physics. This means that time, like space, could be subject to the same physical laws and constraints. This suggests that time travel, while theoretically possible under certain conditions, might be constrained by the same physical limitations that govern other aspects of reality. The idea of traveling through time has fascinated humanity for generations, but it remains a topic of intense debate and speculation. However, some physicists speculate that our universe might be just one of many universes in a vast multiverse. In this multiverse, each universe could have its own unique set of physical laws and dimensions. In this scenario, other universes might have different laws of physics and perhaps even different dimensions of time. This opens up a whole new realm of possibilities and challenges our understanding of reality. The relationship between time, space, and matter remains one of the most active areas of research in modern physics. Scientists are constantly exploring new theories and conducting experiments to unravel the mysteries of the universe. Unraveling this profound connection could hold the key to understanding the universe's deepest secrets, from the nature of black holes to the ultimate fate of the cosmos itself. As we continue to explore and learn, we may one day unlock the true nature of time and its role in the grand tapestry of the universe. Section 6. The unending quest to decipher time. The nature of time has captivated philosophers and scientists for centuries, and it continues to be a source of endless fascination and debate. Is it an illusion, a dimension, or a fundamental property of reality itself? While we may never have all the answers, the quest to understand time is an essential part of the human endeavor. It drives our curiosity, fuels our imagination, and inspires us to explore the universe and our place within it. As we continue to probe the cosmos with ever more sophisticated tools and theories, we can only marvel at the mysteries that time holds. Perhaps one day we will unlock the secrets of this enigmatic force that shapes our very existence. But until then, the journey itself is just as important as the destination.